This is the second half of a practice test from AP Calculus Unit 2. If you haven't seen the first video, go ahead and click the link in the upper right hand corner. In this video we will practice the chain rule and we will find tangent line equations. Number 10. Find f prime using the chain rule. Leave your answer unsimplified. So we can see that we have this inner function and the outer function is the exponent of 2. So to do f prime, I will first do the outer function. So I will move the 2 to the front. So I'm taking the derivative of the outer function and I'm leaving the inner function the same. But the chain rule says I then must multiply by the derivative of the inner function. So using the power rule, 3 times 8 is 24. I reduce this exponent by 1. The derivative of a constant is 0, so I write nothing. So that's it. This is the derivative. For number 11, we will find f prime again, but this time without using the chain rule. So the first thing we need to do is rewrite function f. We have 8x to the third power minus 1 squared. We can rewrite this as 8x to the third power minus 1 times 8x to the third power minus 1. Before we can differentiate, we need to go ahead and FOIL this out. Now we are ready to find the derivative using the power rule. The directions said that calculator was okay, so I'm actually going to take advantage of that because I'm not sure what 6 times 64 is off the top of my head. 6 times 64 is 384. Whoops, 384. X to the fifth power. 3 times 16 is 48. So we have negative 48 x squared. The derivative of a constant is 0, so we write nothing. So that's it. These answers look so different, I was tempted to compare them on Desmos, but here's the first version. Well, actually, here's the first version, and here is the second version. You can see they are exactly the same. Number 12, find all x coordinates at which the graph of f has a horizontal tangent line. You may use either of your answers above to help. I'm going to use the first answer from problem number 10 because it is already in a factored form. So here's f prime. I am going to simplify this a tiny bit by multiplying 2 times 24 and putting the x squared in the front where I am most comfortable with it. So we have this. But if f is to have a horizontal tangent line, that means that f prime must equal 0. So I'm going to set this equal to 0 and solve. Using the zero product property, that means that 48x squared could equal 0, or 8x cubed minus 1 could equal 0. Dividing both sides by 48, we get x squared is equal to 0 and x is equal to 0. Adding 1 and dividing by 8, we get x cubed is equal to 1/8. And then taking the cube root of both sides, we get x is equal to 1/2. So these are the two x coordinates where f will have a horizontal tangent line. For number 13, we consider the function f of x equals x to the fourth power minus 8x plus 1. There is a point on the graph of f at which the tangent line is parallel to the line 4x plus y equals 3. What is the x-coordinate of this point of tangency? So let's start by finding the slope of this tangent line by rewriting this in y equals mx plus b form. Subtracting 4x from both sides, we have y equals negative 4x plus 3. In this form, we can tell that the slope of the tangent line is negative 4. So I'm just going to write m equals negative 4. So this is the slope of the tangent line. Now let's find the derivative of function f, which will give us the slope of the curve at any point we want. So f prime of x equals 4x to the third power, just using the power rule, minus 8. That's it. So this is f prime. So f prime tells us the slope of the tangent line at any x value. But at the point of tangency, we are told that the tangent line should be parallel to this blue line that we were given. In other words, at the point of tangency, the slope should equal negative 4. So let's go ahead and say that f prime at the point of tangency should equal negative 4. That gives us this equation. If we solve this for x, we will have the x-coordinate of the point of tangency. So adding 8 to both sides, we get 4x cubed is equal to 4. Now dividing both sides by 4, we get x cubed equals 1. Taking the cube root of both sides, we get x equals 1. And that's it. This is the x-coordinate of the point of tangency. Number 14. The graph of f given above is tangent to the line y equals 24x plus k, where k is an unknown constant. Find the value of k. We are given an equation of the tangent line, sort of. We don't know what k is, but it is in y equals mx plus b form. So this tells us the slope of the tangent line is 24. In the previous problem, we already found the derivative of function f, so let's just copy this down. F prime tells us the slope of function f at any x value. At the point of tangency, the slope should equal 24, the slope of the tangent line. Let's find the x value where the slope will be 24. In other words, f prime should equal 24, which means 4x to the third power minus 8 should equal 24. Adding 8 to both sides, we have 4x to the third power is equal to 32. Dividing both sides by 4, we have x cubed is equal to 8. Taking the cube root of both sides, x is equal to 2. Remember that f of x equals x to the fourth power minus 8x plus 1. But of course, at the point of tangency, the function and the tangent line intersect. In other words, at that particular point, the function equals the tangent line. So I'm going to go ahead and set the function equation equal to the tangent line equation. And I can solve this for k because we know the x value at the point of tangency. So let's go ahead and substitute 2 in for all of the x values. So 2 to the fourth power is 16, minus 8 times 2, which is 16, plus 1, equals 24 times 2, which is 48, plus k. 16 minus 16 is 0, so we have 1 equals 48 plus k. Subtracting 48 from both sides, we get k is equal to negative 47. So that's it. That's the value of k we were looking for. Using the k value of negative 47 that we just found, you can see that the line is indeed tangent to the function at an x value of 2. Number 15, write the equation of the line tangent to the graph of y equals cosine 2x at x equals pi over 3. When they ask me to write the equation of a tangent line, I always use point-slope form. That means I need two things. I need a point and the slope. I'm going to start with the slope, and then later I will find the point. In order to find the slope, we will need the derivative. The derivative tells you the slope at any x value, including this one. So y prime equals, I can see we will need the chain rule. Let's start by taking the derivative of the outer function, which is cosine. The derivative of cosine is negative sine. So I have negative sine of stuff. For right now, we will leave the inner part the same, but then we must multiply by the derivative of the inner part, which will be 2. So this is the derivative. I am going to rewrite it just slightly by putting the 2 in the front. So I have negative 2 sine 2x. Y prime will give me the slope at any x value, but we need the slope at this x value. So let's substitute pi over 3 for x. So the slope at pi over 3 will equal negative 2 times the sine of 2 times pi over 3. But 2 times pi over 3 is just 2 pi over 3. But what is the sine of 2 pi over 3? Well, we have memorized that the sine of pi over 3 is radical 3 over 2. That means the sine of 2 pi over 3 will also involve radical 3 over 2, but maybe it's negative radical 3 over 2. It just depends on the quadrant. But 2 pi over 3 is in the second quadrant. Sine is a y value. Y values are positive in this quadrant. So the sine of 2 pi over 3 is positive radical 3 over 2. So the slope is negative 2 times radical 3 over 2. But the 2 in the denominator will cancel out the 2 in the front, so we are left with negative radical 3. So this is the slope at x equals pi over 3. So we found the first thing we need. The slope is negative radical 3. Now we need to find the point. Well, we have half of the point already. We know that the x coordinate is pi over 3. So let's go ahead and write that down. Pi over 3, comma, something. All we need is the y value. Well, we have a formula for the y value right here, the original function. Y is equal to the cosine of 2 times x. But this particular x value is pi over 3. So let me just squeeze it in as 2 pi over 3. So this will give us the y value. What is the cosine of 2 pi over 3? We know that the cosine of pi over 3 is 1/2, something that we've memorized. But so the cosine of 2 pi over 3 will either be 1/2 or negative 1/2, depending on the quadrant. But remember, this is in quadrant 2. Cosine is an x value. X values are negative in the second quadrant. So y equals negative 1/2. So now we have the point, pi over 3, comma, negative 1/2. So now we can write the equation of the tangent line. Using point-slope form. Point-slope form goes like this. Y minus y1 is equal to the slope times x minus x1. So we're just going to fill this in using y1 is this y value that we just found, minus negative 1/2 is plus 1/2. The slope is negative radical 3, so I'll put negative radical 3 here in the front. And then we have x minus x1, so x minus pi over 3. So this is the equation of the tangent line. Here it is on Desmos, and you can see that the line that we found is tangent to the function at pi over 3. Number 16, last question. Does the graph of y equals x sine x have a horizontal tangent line at x equals 0? A horizontal tangent line at x equals 0 implies that the slope is equal to 0 at x equals 0. So let's find the derivative y prime, which will tell us the slope at any x value. And then we can check and see if the slope at x equals 0 is indeed 0. So it looks like we will need the product rule. The product rule tells us that we need to take the derivative of the first factor and leave the second factor alone for a minute. So the derivative of x is just 1. And I'm going to leave the second factor the way it is for now. Then I put a plus sign, and then the second time through I switch that up. I'm going to leave the first factor the way it is while I take the derivative of the second factor. So I'm leaving the first factor alone, and now the derivative of sine is cosine. So that's the product rule, and I now have the derivative. So the question is y prime at x equals 0 equal to 0? In other words, is the slope at 0 equal to 0? Well, y prime at an x value of 0 will equal sine of 0 plus 0 times the cosine of 0. Well, we're multiplying by 0 here, so this term has a value of 0, so we can forget about that. What is the sine of 0? I'm picturing my unit circle. 0 is right here. Sine is the y value, so the sine of 0 is 0. So y prime at 0 is indeed equal to 0. In AP Calculus, it's a good idea to summarize. So we can say y equals x sine x does have a horizontal tangent line at x equals 0 because y prime equals 0 at x equals 0.